It's nice to be with you today. I heard a lot during the first hours today. I'm going to quickly introduce my company. My company is an international group, chemical group. We are 45 years old. Our headquarters are in France, and we are now present worldwide. We are a company focused on water treatment. So we are present in any industry using water to increase the efficiency of industrial process and also to treat municipal wastewater treatment in municipal water and industrial water also. As I told you, many industries are using our polymers. We are the world leader in water treatment, but we are also selling this polymer in oil extraction, mineral extraction, paper industries, and we have some sectors, specialty sectors, one of them being agriculture. I heard a lot today about climate change. That is a major issue for a lot of countries worldwide. Me, I'm the manager of North Africa, Italy, and Turkey. I see a lot of issue in agriculture because of the climate change. The soil, because of intensive agriculture, the soil fertility is decreasing. There is also, because of the climate change, less rain. In Moldova, a few years ago, it was more than 350 millimeters per year of rain. 2 years ago, it was only 200 millimeters, and this year was 162 millimeters. So there is less and less water, and this water, the rainfall are sudden, and this is heavy waterfall. So it's hard for the soil to get properly this water. And because of drought, a very long period of drought, we have also highest evaporation. So when you think about all of these elements, the strategy now is to wonder how to save water in the soil. This morning, some ministers have talked about upstream solution to gather water, collect water, in order to use them later on. I will talk about solution, liquid solution to apply in agriculture to save water downstream, directly when we are using water, to save water. The first product is a water saver, is anionic polyacrylamide. This is typically the kind of chemistry used in water treatments to make water potable. In Moldova, a lot of water is used, and irrigation is of course increasing. Some fields that were not using irrigation a few years ago are now using irrigation. And it's mainly drip irrigation today. So this polymer will help the soil to keep a good structure, irrigation after irrigation. As you can see on the wall, the polymer make a kind of coating of aggregates. It's like organic matter, but you can easily use it by applying in drip irrigation. You can notice in the upper left corner that the water infiltration is much better laterally with our product. And on the image done, it's on onions. I don't know if you notice from where you are, but the soil between onions row with a standard irrigation is still dry, while with our product the moisture is totally coming between rows. Let's see a few case studies on orchards, on tree production. This first case study takes place in Spain. We already get a case study previous years, but the grower only say that he's saving 20% of water on the farm. So to be sure, this year, my colleague in charge of Spain has set up at the beginning of year water volumetric counter, and after the campaign, we discovered that finally we have more than 50% saving water on this crop. You can notice on the curves that our product is helping the soil to not dry too fast in order to have less stress to the plant. In this case, there is a such reduction of water, it's because the grower is choosing according to the soil moisture sensor when he is turning off irrigation and when he is turning off irrigation. So we can see at the beginning that the blue curve with flow bond, the drying synergy is less fast. Excuse me. An interesting case studies in my area in Morocco, and a bit complex, but I will try to do my best to explain you. The graph on the left side is the moisture level of the soil in the upper layer of the soil. So that means where the roots are. The gray and yellow curves are without our product. And during the 3 hottest months, so that means in Morocco in June, in July and in September, you have not stable soil moisture, and you have a moisture level that is decreasing very fast. While the orange and blue curves is the soil moisture of the soil with our product. You can notice that even if it's decreasing a little bit, you still have a very good moisture capacity of the soil. Then, if we move to the graph on the right side, you can see that the part beyond the root zone where we did not apply the product, so that means the yellow and the gray curves, we have a lot of waters at 60 centimeters. What does it mean? It means that without our product, this clay soil, clay soil, has a high leaching level, and we are losing a lot of water and nutrients also. So we are not only helping to keep water in the upper layer of the soil, we are also saving fertilizer that are more expensive every year. Then you can see it was a 6 experiment in this farm, and you can notice that we have an average increase of yield by 20%. There was no water reduction in this case study. It's only an increase in yield. And previously today, people talk about the importance of having a good fruit size for exportation from Moldova to other countries. And it's not mentioned on this graph, but we also have an impressive improve on the fruit size of mandarins. You can find on the website of SNF the whole case studies if you are more interested. Then another case study about table grape that took place in Chile 5 years ago. It was our beginning in table grape, and it was a complex study, very interesting study with a lot of parameters that have been monitored. I will quickly go to the most interesting slides. Here on the right, you have two drip lines at 20 centimeters of each side of the plants of the vine, and you see that the water infiltration, there is a lot of leaching, and the water infiltration horizontally is unfortunately very poor. So we have to give more and more water to the plants. While on the left graph, you can see a two-dimensional view. With our product, we have a better water infiltration, and we have, like we noticed on the mandarin just before, we have a very low loss of water and nutrients into the soil. To remind you, it is thanks to the soil aggregate protection with the polymer, because the hydraulic conductivity is preserved. Hydraulic conductivity is the ability of the soil to diffuse the water from an aggregate to another, and it's a key element in the soil. I skip some slide to reach a good point. One other parameter that has been monitored was the climate, the evapotranspiration on the field during the experiment, and it was very stable. So that means that the flow bond application was the only parameters that has been impacted this experiment. A last element we monitor is the water stem potential. That means are the plants available to absorb properly water and nutrients from the soil. In the case of flow bond, we can see that the stem potential is lower. So that means the plants can more easily absorb water and nutrients. So for the same energy, the plant can create more biomass. Sorry, this is the last parameter that has been monitored. This is the NDVI data on the treated field, only on the treated field. And we can see that after the third slide, it was the first application on the 19th of January. We have a very good NDVI on the treated field. An example of return on investment using our product, the water saver for table grape. This is an increase in yield of 2 tons per hectare, with a return on investment of 11. So that means for $1 that has been invested by the grower, you can get back $11. Then this is a photo from this year in Turkey, where we use flow bond DI on cotton. The difference is striking. Excuse me. So then I would like to talk about the second product that is also important for Moldova agriculture. Is an anti-salinity. It's not anti-salinity, as you probably already heard, like calcium amendment or local root area acid. It's anionic polymer, once again, that is coaching salts and pushing the salts down beyond the root zone. So that means that during 3 weeks after the application of this product, you have reduced electroconductivity of the soil, and the plants that was previously suffering from salinity is now able for 2 to 3 weeks to properly absorb water and nutrients. In Turkey, on the cotton field, you can see the difference here in this field. It was very hard for the grower to grow before. We have also helping to cover properly the field, so that means also less evaporation from the ground. This is one of the first very serious study we have made in Morocco with this product. It was with Eurofin laboratory, And we have proven that we are not only reducing salinity during the irrigation, but even 2 days after the irrigation, when the soil becomes dry again, you have not an increase in salinity. That will, the salt that are leached beyond the root zone are not coming up. Another case study in Morocco and Tunisia. This is clay soil with high leaching. We reduced the salinity of this field by 42%, with only 5 liters per hectare. On potatoes again, we reduced the salinity by 32% by applying 5 liters per hectare of flow-bound anti-salt. Another last case studies in Mexico. We put our product in a field of farmers that were already using an anti-salinity product that was a mix of carboxylic acid and something else, and the efficiency is much better with our product. You can also find the whole study on our website. Thanks a lot. If you have any question, we have a little stand on the corner. You can come and ask questions.